Okay, welcome to another worked solution video for A-level physics, AQA. This is a mechanics question to do with moments. Pause the video and read the question if you haven't already. Okay, so here we've got a mobile, you've got a string, a beam. It tells you that the beams somewhere, it tells you that the horizontal bars have negligible mass, so you can completely ignore them. First bit, state the principle of moments. Sum of clockwise moments is equal to the sum of the anti-clockwise moments when in equilibrium. Okay, this is something you definitely need to memorize. It comes up all the time and it's very easy to lose marks on. If you don't say the sum of, if you just say the moments clockwise equals moments anti-clockwise, you won't get a mark for that. So you've got to be really clear about what you're saying here. Alright, the next step says the weight of the fish is 1.5 newtons. Calculate the weight of the butterfly. The fish, the butterfly. So you can basically ignore all of this and just look at this. Imagine you've got a little pivot here. It's quite a straightforward moment question. Okay, so you can start with moments anti-clockwise equals moments clockwise. Okay, got a moment anti-clockwise of 1.5 multiplied by a distance of 0.04. That should be equal to the clockwise moment this way. So remember, a clock turns that way, doesn't it? So the clockwise moment produced by the butterfly will be the force of the butterfly, or the weight of the butterfly, multiplied by a distance of 0.120. Okay, so dividing both sides by 0.12 gets me 1.5 times 10 to the times 0.04 divided by 0.12, and calculating this gives me an answer of 0.5 newtons. Okay, bit of a squeeze to get this in here, but yeah, set your work out nice and neat, not like me. Right, next step says calculate the weight of the bird. Alright, so here we have the bird, and we've got all this stuff here attached by this string. So I'm just going to pretend that all this stuff is just one weight acting down of 1.5 newtons plus 0.5 newtons, so 2 newtons. Okay, it's acting as though it's acting from this single point here, because that's basically what it's doing. Okay, so again, moments anti-clockwise should be equal to the moments clockwise. I've got one anti-clockwise moment, which is the bird. So it's the force of the bird, or the weight of the bird, times the distance of the bird, which is 0.150. Okay, should be equal to 2, which is the force, times this distance, 0.05. Okay, again, dividing both sides this time by 0.15. So divide this by 0.15 and this by 0.15. This cancels out, so I can calculate F, and F comes out as 0.66666 recurring, so I'm going to give my answer as 0.67 newtons. Okay, so the bird, sorry, a bit of a mistake there with my pen not registering properly, 0.67 newtons. Okay, so quite a bit of work to do just for 2 marks, but not too bad. Alright, so now part C. The system is displaced so that the lower bar is no longer horizontal. Explain briefly whether this has any effect on the equilibrium of the system. Okay, so what we're imagining here is, imagine that this gets tilted like that. Okay, what's actually going to happen? Well, the force of this thing here is going to be acting further over this way, so this distance of 0.04 will get shorter from there. Similarly, the butterfly is also not going to be now at a distance of 0.120, it will be a shorter distance. Okay, and as it happens that the amount this one got shortened by and the amount this one got shortened by proportionally stay the same. Right, so it actually won't have any effect. Alright, so this will have no effect, as the lower the bar tilts, the horizontal distances of the forces from the pivot for both the fish and the butterfly get shorter by the same proportions, so you don't have any effect due to it. Right, I hope you found this video useful and helpful. If you have, please comment, like, subscribe and share. Thanks for watching.